Ladies and gentlemen, boys and girls, behold, for in oi, ah, for in my presentation, I will present to you the most beautiful thing that has ever been thought of in human history. I think we're all entitled to opinions. The Drake equation. Have any of you heard it? Yes? No? Silence? The Drake equation is basically an equation that says, what is the chances of there being another planet in the universe that can sustain life? And not just life as in cockroaches or mosquitoes and ants, but really intelligent species like us. But then that raises another philosophical question if we are intelligent or not. But like, we're not here to talk about the Drake equation. It has been performed or spoken about many times in TEDx, in YouTube, in Facebook, social media. It's starting to get boring now. So let's go one step further. What's bigger than a planet? Anyone? High school physics. What's bigger than a planet? A star. What's bigger than a star? The galaxy, the universe. Have you ever wondered, if there is truly a multiverse out there, then what are the chances of there being another universe, a universe like ours, that can sustain life? You probably haven't. Before I talk more about the theory that I'm going to talk about, we need to establish what is a multiverse. I'm fairly confident that most of you have not heard of that term. What a multiverse is, basically, it originated in the 1970s by a man called Hugh Everett, a very young, enthusiastic, aspiring physicist. He created what is called the many-world interpretation of quantum mechanics. Basically, what he said is that the quantum mechanics says that you can have different possibilities, possible states of things. And what if you apply that to the universe? Then does that mean that there are many universes out there? We don't know. At that time, physics is not as developed enough as today, so they couldn't really tell. Until now, we still can't really tell. The Big Bang happened 13.8 billion years ago. There is not much evidence left, other than the CMBR, which is the cosmic microwave background radiation. But enough about multiverse. I think you want to know how special we are, if there is another multiverse out there. That sounds so much more interesting than what it actually is. So, before I tell you that, we play a game. Now we need audience interaction. It's called the before and after game. I invented it, credits to me. So what happens is that I'm going to show you two pictures out there, two pictures. And you're going to tell me which one came before and which one came after. All right? And as with any game, we need rules. Here are the rules. The person is mixing the Rubik's Cube. Oh yeah, it's going to be a picture of Rubik's Cube. If you have never seen it before in your life, don't worry, it's that. A cube. So the person is mixing it, is purposely mixing it, and the Rubik's Cube always starts off perfectly solved. Okay? You ready? Round one. You have picture A over here, perfectly solved. Picture B, mixed. Which do you think came first? Which do you think came first? Left one, A. Why? Because it's fully solved. I told you in the rules, right? It's easy. What about this one? Can you tell which came first? You can't. Because they're both mixed. So what am I getting here? I'm showing you 4 pictures of Rubik's Cubes. Have I wasted 30 seconds of your time? No, I haven't. This is what we call, through this model, I have demonstrated what is known as the second law of thermodynamics, the law of entropy. If you have never heard of entropy, don't worry. Entropy is known as the disorderliness of a system, or how many possibilities can it exist in. If we go back, this one, how many possibilities can this exist in? 1. All same color, all sides, right? What about this one? How many possibilities can this exist in? Take a guess. Any guess? Be wild. You've probably never heard of this number. 1,000,000. Bigger than that. 2,000,000. 43 quintillion. That's how much it is. The entropy is directly proportional to the number of microstates, or the possible combinations it can exist in. So this here has extremely high entropy. This here has extremely low entropy. And there is an increase in entropy, which is why you can tell time. In Stephen Hawking's book of A Brief History Through Time, he mentions that there is 3 arrows of time: the psychological arrow of time, the thermodynamics arrow of time, and the third one, the cosmological one, which we will not touch on today. He says that the human arrow of time basically comes from the thermodynamics arrow of time. Since the second that we are born, we are suited to this idea of the entropy is always increasing. Because this is why a cup of hot coffee at 83 degrees left in room temperature, it will cool down to match room temperature, not the other way around. Which is why an ice cube, 0 degrees, it would melt to room temperature, not the other way around. Entropy is always increasing as a whole of the universe. Maybe right now we are decreasing the entropy by providing air conditioning. But the energy to power the aircon is coming from the generator. And in the generator, the heat dissipated is increasing the entropy. And that increase is larger than the decrease over here. So as a whole in the universe, the entropy is always increasing, which is what we model in this game. It increased, so you can tell time. This has equal entropy. They both have 43 quintillion possibilities. This is what we call thermal equilibrium. So why is this important? Why do we need to know the concept of entropy? This is because what I'm going to introduce you to the theory of the universe, or what is known as the Roger Penrose's ridiculous number. Have you ever heard of him, Roger Penrose? No? Yeah, I guess not. Before I tell you that again, disclaimer, there are many theories out there, because nothing can be justified. The Big Bang happened 13.8 billion years ago. It's hard to find evidence, solid proof. So there are many theories out there. This is not the only one, okay? Please don't be misled. And now we introduce it. You ready? This is the founder of the theory, Dr. Roger Penrose. He claimed that the chances of there being another universe, if there is a multiverse, the chances of that is 1 in 10 to the power of 10 to the power of 124. Now, I personally cannot comprehend that number. So I'll try to make it easier. Imagine that you take a singular atom from the entire baryonic mass. Baryonic, keep in mind 95% of the mass of the universe is made up of non-baryonic matter, not atoms. You take it from the entire baryonic mass of the universe. Okay, you take an atom, you pop, take one, and then you make a mark on it. You can draw a little heart or a star or a cross or a dot. You make a mark. You put it back, like putting it back in the bag, you know. And then you shake it, shuffle it, randomly mix it. And then you reach your hand into it, you grab another atom. Oh, it's the same atom. So magical. Now, ladies and gentlemen, how many times do you think that I have to do that in a row? To at least come close to 1 in 10 to the power of 10 to the power of 124? Take a guess, a wild guess. We had 43 quintillion just now. Yes. 5. Any more guesses? More than that? Anyone? Yes. 24 billion, that's a bit too much. Honestly, there's a lot of matter in the universe. It's actually 65. You have to do that 65 times in a row to even come close to 1/1000th of 1 to the power of 10, 1 over 10 to the power of 10 to the power of 124. That's how rare, he says. Oh, and by the way, side note, just saying, fun fact, Dr. Roger Penrose, I just ruined the surprise. Dr. Roger Penrose, he is one of the only famous scientists from the 20th century still left right now. Unfortunately, death is a normal thing, and most of the famous scientists, like Erwin Schrödinger, Werner Heisenberg, Niels Bohr, Max Planck, they unfortunately all passed away. He is still alive. He's in Oxford. You can go and meet him if he gives consent. Consent is everything. So, after 10 minutes or so of suspension and build-up, do you want to see the most beautiful thing in the world? Yes or no? Yes. I've just shown you, but pretend you haven't. There we go, ladies and gentlemen. The most beautiful equation in this world. The Boltzmann equation of entropy. S, entropy, equals to K, the Boltzmann constant, multiplied by log of W, W being the microstates of any system in given time. What Roger Penrose did was that he did some fancy mathematics. He said, what's the possible combinations of our universe that can exist for us to be existent? You know, our universe is really, it's hard to come by, you know. We need to be in a Goldilocks zone, a perfect zone. If we're too close to the sun, then we burn. If we're too far, then we freeze. Or if the mass of the neutron is not 1, or if the if the charge of electrons isn't perfectly -1, then it won't fall into orbit. Or like, if there isn't as much critical density, then it won't reach a point of expansion, and the universe would have never expanded to this point. So, from that he concluded, why am I doing this? From that he concluded that the possible combinations of our universe, W, the microstate, is extraordinarily low, astronomically low. And if you all know high school mathematics, a log of a low number gives a low number. And you multiply by K, a low number, Boltzmann's constant, it gives you S, entropy, as a very low number, the lowest it can be. And from that, he concluded that for there to be another universe out there with the same low entropy as our universe is 1 in 10 to the power of 10 to the power of 124. It used to be 123. A few decades ago, he changed it to 24. So maybe he would change it to 25 next year or next year, I don't know. So what am I getting at here? Well, first of all, I hope you all learn physics. It's really interesting. I've just shown you why. What am I getting at here? Are we special? Do you think we are? I've just shown you one theory. The chances of our universe is 1 in 10 to the power of 10 to the power of 124. Are we special? Is this really the possibility, the chances of there being another universe in the multiverse where civilization can truly thrive? Thank you. I hope you learned something.